All right, so hi everyone, I'm Liying, and before getting started, just a few words about me in case you missed the introduction in the beginning of this workshop. I'm currently a postdoc in Academia Sinica in Taiwan. I graduated from the University of Washington, and I'm very interested in open science and have many years experiences during my PhD working on reproducible research using R. And today I'm going to talk about open data. In this presentation, I will start with the definition of open data types, principles for data sharing. Then I will explain why it is important to share our data, what's the reasons and benefits. Next, I will talk about how to make our data open by giving you some examples of data sharing types of repositories that we can use and demonstrates the workflows. In the end, I will suggest some small steps that we can get started with open data. So what is open data? Open data means we share our research data with everyone. The data can be in any formats like a Word document, Excel file, or a text file that are analyzed in your research. The most important thing here is the data you share must be openly available. That means everyone can find and access it easily and freely. In archaeology, we usually go into field to collect data. It's very common we have data that describes like types or textures of artifacts or numbers like lengths, width or height of a pot or a stone pool. There should be no problem to share them, but sometimes we may have sensitive data, for example, site location. If we make it open, it may lead to looting or there could be some other national security concerns. Sensitive data also includes data related to human remains and indigenous people. In this situation, it becomes an ethical issue. We may get into trouble if we just make sensitive data open without consideration of the preferences of other interest groups. So to make good decisions to open data, there are some principles that we can follow to ensure the best practice for our work. Here I will talk about two major categories we will use in archaeology. First is open data with FAIR principles, and another one is open data with CARE principles. So there are two categories represent different goals with different degrees of data openness. First, let's look at FAIR principles. The goal of FAIR is to optimize the reuse of data so that the whole community research community can benefit from it. Based on this goal, the FAIR principles describe the ideal way data should be stored and shared. The FAIR data should meet laws for standards, findable. That means data can be found easily for both humans and computers. You can easily search it online, and data should be accessible. That means once the user finds the data, they can access it and maybe download it. And the third is interoperable. That means the data needs to be integrated with other data, along with applications or workflows for analysis, storage, and processing. And the final one is reusable. That means to maximize the reuse of data. So to do this, we may need to describe our data in details. So it should be well described so people that can know how to reuse it. And this is a paper that describes FAIR principles in detail. In the paper, they also provide some checklist for those four principles that I just introduced in last slides. So guide you how to create a FAIR data. So you can check it if you're interested in. And in archaeology, there are also many great works that demonstrate how to make FAIR data. For example, Emma's work for FAIR vital data and fair data for prehistoric mining archaeology and fair radiocarbon database. Those works are great examples of open data practice that we can follow. So now I'm going to talk about CARE principles. CARE principles is another category designed mainly for indigenous data governance. So they are developed by the Global Indigenous Data Alliance in 2019 to complement the existing FAIR principles to engage with indigenous people's rights and interests. CARE has 4 principles that stress collective benefit and authority to control data, responsibility, and ethics. So the purpose is to ensure roles of indigenous people in open data decision-making process and protecting data if needed by the communities. And here is a paper describes CARE principles in details and provides some guidelines to make CARE data. Also, you can check it if you're interested in. So we learn those two major categories of principles for data sharing. One is FAIR principles, which is data focused, and another one is CARE principles, that is people and purpose oriented. Those two categories approaches can be combined as the best practice. That means we make our data open as much as possible with FAIR, but closed as necessary with CARE. So now let's look at why it is important to open up our data. There are many good reasons to share data with others. In general, for our own goods, sharing data can increase the visibility of our research, and for the community and public goods, it can increase the reuse of data to advance scientific progress in the long run. So you can also find some other more reasons if we open up our data. And here shows you the studies that demonstrate clear examples that data sharing can increase citation rates of papers to gain more academic impacts. For wider, for example, this article, it described the increased citation rates, and you can see so you can clearly see the number of citations increased if they share their data by this box plots. And this is another paper that describes also increased rate of citation when they share their data with the other people. And for wider communities, data sharing also improves equity in participation in research, because data should not be only controlled by a small group of archaeologists, and it also helps with build new collaborations and enhance the reuse of data. So that's about data sharing. What's the benefits we have? And next, I will talk about what we do to share our data. There are many options we can choose for data sharing. And for example, we can share our data by submitting as a supplement material with paper, or you can posting your data on websites, or publish your data as a journal article. And the last one is you can upload to online repository, and I highly recommend the last one, and I will talk more about it and demonstrate how can we make it later. So first is we can submit data as a supplement material with published journal article. And this shows you an example of one of my papers that, that people can download the data from the website of the journal. But it has a shortcoming, which is not open enough when your articles are published in paywalled journal, because that restrict access to content for people who don't subscribe it. So this is not a very good method. And we can also publish our data set in like data journal as a data paper. For example, Journal for Open Archaeology Data is a good place to publish your data. And also recently PCI community is also another great way to publish your preprint, including dataset in archaeology. And here shows you an example that they submitted their preprint to PCI and got recommendation from the reviewers, and later they submitted to the Journal of Open Archaeology Data Journal and got published. So this is a good options we can take to make our data more accessible. And the method I recommend here is to upload our data to online digital repositories, because it is the easiest and reliable way to make our data open. There are many different digital repositories that we can consider. The repositories on the left are better ones. So you can see, for example, Open Science Framework, Figshare, Zenodo, and the Dataverse projects. So they are better because those repositories, their mission, they are a trustworthy digital repository, TDR. So the mission of TDR is to provide reliable long-term access to manage digital resources to its community now and in the future. So they allow users to generate shareable DOI, which is digital objects identifier. A DOI is a unique number string that identifies content and provides a persistent link to its location on the internet. So once you have a DOI, you don't have to worry like it may be gone in the future at some point. And the GitHub here, GitHub on the right here is also a good repository, especially for like coding data. Actually, I use it a lot, and I quite like it because it's very convenient to connect to our Markdown. So I use it very often, but GitHub is not a TDR, so it cannot ensure long-term access. However, you can link your GitHub to OSF, for example, and I believe other service also, they provide some functions to link to your GitHub so that you can ensure a long-term access storage. So now I'm going to show you how to upload data to online repository using OSF as an example. So first, you need to create an account which is free for everyone, and then create a repository. And this is something that you will see after you created it. Create a repo, you give it a name, and here you can see the name of my repo is, I just give a random name my data. And there are two ways you can upload your data to the repo. First is you can simply drag and drop your files to this space to upload, or you can click on add-ons over here and click on it. This is a function allows you to mix and match resources on cloud storage, such as Dropbox, Google Drive, or GitHub. So in my case, I usually like click on add-ons to add to connect to my GitHub repository, because I have everything on GitHub, and this is the most convenient way for me to do that. But if you have your data like stored in like Google Drive or Dropbox, then you can choose, you can also use add-ons, or you have data stored in your computer, then you may want to choose this way, just like drag and drop it to this space, then you will be automatically upload to your OSF repo. So now this image shows you an example to link GitHub to OSF or other like Dropbox or Google Drive. So it involves two steps. First is to click on add-on and then select the external. Like you can see this window. It selects to select external service you want to connect to. Hit enable. Then you will see a pop-up window like this to ask you to select the repo in your GitHub repository for connecting. So you need to. So that means there are already some repositories in your GitHub so that you can do this. And just click on the one you want to connect to. And this is also the step for configuration. So those steps are very straightforward and easy to learn. So if you want to use add-on, just click on it and choose whatever server you want to add and configure add-ons. And once you uploaded your materials, you can see all of your data showing up on the left. This is an example of one of my projects. You can preview the data by click on the items. And this is an example. When I click on raw data, I store this burial data into this folder. And after I click on it, you can preview everything. And also, if other people look at it, they can also download your file. So this is a good way to make your data more accessible and also allows other people to reuse it. And now I'm going to talk about two other important functions that I want to stress. One is DOI, and DOI, to generate a unique DOI, you need to make your project public first and then click on it. Then it can automatically generate a DOI link, something like this. This is like a URL link. And this is a permanent and persistent link, and is also very convenient for people if they want to refer to your work. So I highly recommend you to, like, if you have OSF repository, make it public and generate DOI. And next important function is to add a license to your project. So you can see the license over here. And adding a license is very important because it allows other people to copy, distribute, and reuse your data while allowing you to retain copyrights. So there are many licensing systems we can use. Among those systems, the Creative Commons, this one, licensing is the most widespread one. And you also have other different licensing services like Open Data, Commons, and General Public License. But here I recommend to use Creative Commons. So Creative Commons provides different licenses to indicate conditions for use, from the least open to the most open. For example, you can see CC0 here. So this means you waive copyright interest and dedicate it to the public domain. CC BY, this one allows other, it means you allow other to copy, remix, and redistribute with appropriate credit to the original author. And also we, I think for my data, I use this one, CC-BY. And CC-MD means it did not allow people to modify your work. And next one is share alike. And this one means copies or adaptations of the work needs to be released under the same license as the original. The final one is the copies cannot be used for commercial purposes. So if you add more terms to your license, then your work is list open. So to optimize the reuse of data, you may want to choose CC BY or CC0. So this is license from Creative Commons. So now I will briefly show you the workflow I've been using for my own research with open science practices. And I just demonstrated it using this poster. And this is a poster that I presented in the CAA Australasia conference, I think last year. That shows the workflow I've been using to ensure open data, open method, and open access using R with GitHub and OSF. So for all of my writings, I write them using R Markdown, which is the image you see over here. This is when you open up Markdown, it looks like this. And Markdown is very convenient because it can combine text and data. So for my practice, I use research compendium. So what does that mean? It means it can combine text, data, and code for analysis all together in one single document, which is R Markdown. This allows me to analyze and visualize data in one R Markdown document. So you don't make any mistakes, like by copying, pasting your figures or data or some final outputs from another system to your documents. And to better manage different versions, I also use version control system Git with GitHub to save and keep track of my changes to those files, to the R Markdown files. And after my writing is done, I use OSF to store all of my research materials, like I demonstrated in previous slides, that you can connect your OSF to GitHub repositories. So after I do that, all of those materials I stored in GitHub will show up in OSF repositories. And it can ensure a long-term data preservation and make the paper openly available by uploading a preprint to Social Archive service. So this is the Social Archive service for preprint uploading is my last step during this open science workflow. And why I do that is because, as I said before, some publisher is paywalled, and you have to pay for it in order to read articles. But if you submit a preprint to Social Archive system, you can do this at any points of your writing, even when you finish it or after you publish your paper, you can update your preprint. And in this way, the preprint is openly available for everyone. So everyone can see it easily. They don't have to pay for it. And so this demonstrates the workflow I've been using for all of my writing, my papers, and also my dissertation. And it's practical and also easily learned, and it can be applied to many other types of research. So if you're interested in this poster, here is the link you can refer to. Also, another important thing is in all of my papers, I normally put a paragraph that describes, they will tell people how to find and reuse my data and code by providing a link to my repositories. So here you can see a link to my OSF repositories. And also I will tell them the license types I use. So here for data, I use CC0. So that means I waive my copyright. So everyone, they can just reuse my data. And for figures, I use CC BY. So that means they can use it, but they need to give me credit. So those are something important you can't put into your paper to communicate how people can reuse your data when you publish your paper. So this is my open science practice. So I think this is the final slide, and just a recap. In this presentation, I introduced concepts of open data sharing principles, including FAIR principles, with the goal to optimize the reuse of data, and CARE principles that are people-oriented as a complement to FAIR principles. And I also talk about many good reasons why we share our data. For example, data sharing can increase citation rates and enhance the reuse of data by others. I also demonstrated how can we make our data open using OSF as an example, and briefly talk about a workflow with R and GitHub I've been using for open science practices. So if you are totally new to open data, I want to suggest some small steps for data sharing to get started. First is to think about your data with FAIR and CARE principles when making decisions to make them open. And second is to choose a digital repository server you like. So we introduced like OSF and also Zenodo and Figshare. So those are good servers that you may want to use for sharing your data. So when you're ready, you can upload your data there to make it openly available for everyone. So so those some small steps that you can get started with. So this is my presentation. Thank you very much.